Okay, another application of area is geometric probability. Okay, so you've seen probability before. It might have been a while. I'm sure you did it in junior high a little bit. You're probably touched on in Algebra 1. Problem with probability is there's not just a year where you study probability and statistics until you get to AP statistics. But a lot of the basics is kind of spiraled in through a lot of classes. Some teachers get to it, some teachers never do. So the problem with this is some of you are going to know this very well and some of you aren't. It just depends on who your teachers were. But probability is basically chance. It's what is the percentage of me winning, which percentages are ratios because it's everything out of 100. So it goes back to a lot of the proportions that we've already talked about in this unit. Proportions are really, really important concept for all math subjects. Okay. This one's kind of a fun one because it has to do with games and stuff. So you could kind of apply this to all different kinds of things. Alright, so the basics is you want the part over the whole, which you've already understood this ratio concept when we did our circle sections. So let me give you an example. If I tell you that that's 3, and I want to know what is the chance that I will throw a dart at this shape in the green area. Okay. Now obviously this is, assuming that you're not aiming or anything, that you're just randomly throwing it up there. So we are assuming a little bit of randomness to this problem. But you have the area of the part. How do we find the green area? Well, that's easy. We're going to take the square and subtract the circle. Okay, we did this the other day, so in sections with the composite figures. So, area of the square. Well, what is the side length of the square? How do we find this length right here? Well, if the radius is 3, remember the radius can be drawn anywhere. Can I draw the 3 here? And can I also draw the 3 here? So that makes this 6. So the area of the square is 6 times 6, which is 36. And we're going to subtract the area of the circle. Pi r squared. Remember the r was 3, so that's going to be minus 9 pi. Remember, leave it in terms of pi until the very end, that way you're not getting any rounding errors. Okay. So actually I might just leave it like this for now. I'm not even going to turn it into a decimal yet because I still have to do the ratio. Alright, now I need area of the whole. Okay, which is just the square. We already kind of did that over here. 6 times 6, which is 36. So, my ratio is 36 minus 9 pi over 36. And when I type that in the calculator, making sure that this goes in parentheses. If you don't put that in parentheses, it's just going to divide the 9 pi, not the whole thing. So, 36 minus 9 pi divided by 36. I get 0.2146. If it wants it as a, now they can ask for ratios, they can ask for percentages, they may ask you to want to just leave it in a decimal form. It depends on the question. If they want it as a percent, you just multiply by 100, which gives you 21.46% chance. Okay. Here's another example. let's say you're playing a board game, okay, and this is the spinner. And all these are different colors. Okay. And there's your pointer, and it spins in the middle, okay? You're playing some kind of board game, and you're trying to make a decision. Do I spin, or do I take a card? And when you spin, you need to land on orange, okay? So you want to know what your chances are, okay? Let's say this is, that looks like about 50 degrees, okay? What's the probability of landing on D? Okay, remember it's the area of the part. The part I want is D. How do I find the area of a sector? Okay, this is the proportion stuff. And I know some of you were using the formula out of the book for finding the area of these sectors. I don't mind you doing that. I'm not going to count off points. But the reason why I was really stressing this proportion is because 2 years from now, when you have to, if you're trying to take your SAT again or something, you're not going to remember that formula. But if you can understand the concept of a proportion, then you can still remember how to do this problem. That's why I don't like the formula. Yes, it might be simpler right now, but you need to do whatever's going to give you retention for later on. And proportions is something that you do over and over and over again in different subjects, so it's something that you can retain better. So my suggestion was to do the angle ratio, which is 50 over 360. That represents the angles, right? Smaller number, big number. And then we want area, so I'm going to do the area of the segment, or sector, over the total area. And let's say this is 10 centimeters long. So we'll do pi 10 squared. Cross multiply and solve. 50 times 360, divided by 360 times square pi. I get 43.633. And I want the area of the whole, which is just pi r squared. 314.159. And then just make your ratio. Okay. How about one more quick example since we're only at 6 minutes. Okay. So again, we're finding the probability of the shaded region. Okay. We don't have a formula for this shape. The only way to find this area is to take the trapezoid and subtract the semicircle. Okay. So for the part, the area of the part I want, we're going to do the trapezoid minus the semicircle. So for trapezoid, it's 1/2 height B1 plus B2. And for a semicircle, we have the area of a circle and divided by 2. So those are our formulas. What is the height of my trapezoid? It's not really given in the picture, but it sort of is. If I know that my radius is 5, then that also happens to be the height of the trapezoid. Okay? So we have 1/2, 5. B1 is 10. Uh-oh, what is my B2? That's also not labeled in the picture, but again, if my radius is 5, oh, I should have made this something different. I didn't realize that was going to be, let's make this 15. Okay, then the top part of my trapezoid is going to be 10. Okay, this one's easy. It's just pi, 5 squared, divided by 2. Now you can get out your calculators. Oops, I made a mistake here. That should have been a plus sign, not parentheses. Let me rewrite that whole thing. 1/2, 5, 15 plus 10. This is the height. That's my bottom base. That's my top base. 10 plus 15 times 5. I get 62.5 minus 9.27. Remember, when you're putting this one into the calculator, that this has to go in parentheses, or it's just going to divide the 5 squared. It's not going to divide the pi. So anytime you have multiple things in the top or the bottom part of a fraction, remember you have to use parentheses. Okay, when I subtract these, I get 23.23. Okay, that's the part. That's the orange part. But I also need the whole. And the whole was just the trapezoid, which we already found. That's 62.5. So now I make my ratio, the part that I'm looking for, over the total area. I get 0.3717, which is 37.17%. Okay, so you get the idea. It's just the area of the part that you want divided by the total area, just like we did on circles.